In this series of videos I'm attempting to repair and restore a pair of HP9120A printers. So far in this series I've completely rebuilt the print mechanism out of one of the printers. That's almost completely. I haven't done the print head yet, we'll come back to this later in this video. And I've also now replaced the drive belt. And what I've noticed with the original drive belt is it went straight from the motor pulley straight around the pulley that's on the end of this drive roller. And the problem with the pulley on the drive roller is kind of a Bakelite material. It's got a habit of breaking up very slowly, kind of bits chip away and it gradually loses its profile. Now you could in theory replace it. Wouldn't be easy. It is bonded to the roller. Also there's a pickup magnet in there that's used to detect the position of the roller as it rotates. That's what this small board's for, that goes in this location. And I'd found that there was a lot of wear on the shaft that this roller runs on. It's very badly worn, and that was on the pressure side, that was on the front side, and that's because in order for the motor to be able to properly drive the mechanism, the belt had to be very tight, and if you didn't have a lot of tension on the belt it tended to skip teeth, and that would either damage the belt or the pulley, or the printer just wouldn't work properly. So what I've done when I've replaced the belt is I put a very slightly longer belt on. It's got 5 more teeth than the original, and although you probably can't see it very well, it means I can route the belt underneath this shaft. This is the main mounting shaft. It doesn't foul on anything, and although it looks like it might wear the belt out, remember that the motor turns clockwise. When it's running, the tension's on the bottom of this belt, which goes straight to the pulley, and the top will it'll leave the roller and almost be flicked underneath this, so it will be barely touching it. It also means I can have very low tension in the belt. It's only about a quarter of the tension that was required for a belt running straight across. Now I don't like modifying machines, so this is not really modification. I haven't really changed anything, I've just fitted a slightly longer belt. But what it resulted in was the amount of force needed to turn was quite high before, whereas now it's almost no force whatsoever. It feels much smoother. You haven't got this drag trying to pull it, and if I try to engage the drive mechanism, so we'll engage the clutch while I'm rotating it, and you can see that's now got the head moving across, but even now it's taking very little force to turn this motor. You see it'll go across, get to the end, reverse, it'll drive the rubber roller around to advance the paper, but even now the amount of force required is very low, so this does seem like a much better way to drive the printer. If you want, of course, you could just put the original length belt. Now the original was a DP40 belt, so it's a DP40 pitch belt, and it had 190 teeth. The one I've put on here has got 195 teeth. It's actually this belt, so that's the one I've fitted. But if you wanted to fit the original, then just go with the 190, but as I say, it does need much more tension in order to work properly, and again I didn't want to wear out the shaft. Okay, so that's now working, and it's all nice and smooth. It does exactly what it's supposed to. The clutch works, the switches work, the 2 clutches to drive the rubber roller work. I can refit this sensor board, and that will be this pretty much fully assembled. There's a guard to go on the belt, of course, and I've got to screw this top cover down, but other than that it is now pretty much complete, except of course for the critical part on the front, which is the print head. Now in the previous video I went over various ideas I was having on how to go about repairing that, and what has happened is the flat flex cable had failed. It failed where it joined onto the tungsten print head, and also there were various breaks along its length. There's a lot of corrosion in this, and basically it's scrap. There's no way to recover this. So what I've done is I've designed a new version of this. It's pretty much identical to this, apart from there are some gold contacts at this end. There are gold contacts that connect to the PCB, and I've done the same at the far end. Now I will do some close-ups under a microscope in a future video showing how I go about doing this once the replacement cables come in. But what I'm doing is I very carefully removed the tungsten part of the cables. This is now just the tungsten section. Someone did suggest spot welding something onto this, but good luck if you try that. Just bear in mind this is irreplaceable, so I've kind of got one shot at doing this, and if I destroy this, then the chances of getting this printer working properly are pretty much zero. So I need to make sure I take a solution that's going to give me a fairly good chance of getting this working. Now this section fits into this print head. This sits on this bracket and moves along, and it rocks to engage or disengage the tungsten fingers with the paper. This section fits in this slot, and there's a slot it comes through. So I'll go over this in more detail and do some close-ups in a future video. Once it's fitted through, there's this wedge that fits in here, and that kind of wedges and stops the end of the cable from moving in and out, and you just position it so that the fingers are just in contact with the paper when it's in its down position. And then there's an adjuster screw on the back to set the tension, and that's where I want the join to be in my cable, so it's actually held together by this wedge. And so I've cut the cable head off so that I have access to the tungsten part that I need. Cleaned it up. It's cleaned up nicely. I'd have to be careful not to put solvents on here. I don't want to dissolve the glue and have the tungsten fall off. And then I've designed a new cable. This is a mock-up of it, but this is how it will look. So it sits on the machine like this. This end goes onto the PCB, and you can see you've got contacts on the bottom as per the original, and then the other end will be connected to this in this position, so it will effectively stick on there using the double-sided tape that I showed in the previous video, and then there'll just be a layer of Kapton tape around the outside of that. But when this is put into the print head carrier, then this join section will be in the area supported by the wedge, so it'll be effectively holding the taped section together. And obviously newer flex cables, it'll look very similar to the original, it'll just be a bit more resilient, but it will look identical. I've made it as much as I can exactly match the original, so it should look authentic, and certainly in terms of the connections it should be a bit more reliable. So as soon as they come in, I've got them ordered, as soon as they come in I'll do a completely separate video on rebuilding this print head. But the next thing I want to do is look at starting the reassembly of the main printer bodies, so we'll start looking at that and see how we're going to go about starting the reassembly and the rebuild. So just a quick update on the calculator itself before we start looking into the printer main chassis. Been doing a bit more work on this, mostly testing. Been testing it probably for a total of about 15 hours now, and it seems fine. Can't find any faults with it. And I have also replaced the register display. If you recall, this was missing off this. In fact, I had the housing, but I didn't have the front overlay for it. I've got two of these machines, and the overlay in the other unit is fine. It's got the original overlay. This is a little insert that provides this text, but on this unit it was missing. fact, it was there, it just didn't work very well. Also, what I've done, if you recall, there was a lot of distortion on the CRT, and this corner was kind of sagging down and looked fairly poor. And as you can see now, it's nice and straight, and it does now work as it's supposed to. So that's working fine. The overlay and register indication looks fine. By the way, if you've seen flickering on the video, it's not present in real life, it's just an artifact of the camera. So the correction to the distortion on the CRT is just simply a case of, I've just attached a small magnet. It just needs to get the right strength magnet, put it in the right location, and it will correct the geometry of the tube. It's a fairly common problem with this type of machine, and it was a very common problem on old black and white televisions as well. And this is basically how they went about correcting it. So we've now got a very nice linear and properly square display. The register display also looks fairly good. I'll just dim the lights so you can see those a bit better. And as you can see, it all looks very nice. It's much better. Nice dark background, nice bright text. So the way I went about making the inserts, so I've got a couple of extra ones I made. If you've tried making these, you'll know that if you just try printing onto clear acetate, then the light shines through what should be dark sections. Laser printers don't print heavily enough. There's two ways I can go about doing this. If it's a larger text, I'll use the laser cutter to make something suitable. In this case, because the text is so small, what I did was to print off onto acetate. As I said, a single layer isn't going to do the job, so each of these is actually 3 layers. So it's 3 layers stuck together, but because the acetate is clear, you'd be able to see through where the writing is if you just left them as clear. So what I do is I bond each layer together using double-sided tape, and it acts as not only the method to hold them together, but it also acts as a diffuser. So each of the layers diffuses the light, and it gives you this nice even appearance rather than getting bright spots where you can see through the text. This then just clips into the housing, and as you can see, it works fine. So that's now working. The calculator is working fine. But the next step, as far as the printer is concerned, is dealing with the chassis. I won't let go of it because there's no foam on this, but we need to have some kind of foam backing on this. The original rubber surround had completely disintegrated, so what I'm going to be using for this is some of this self-adhesive rubber strip. This is quite soft, but when there's quite a big area, it will give the right amount of support, and it's the right thickness. So all I have to do now is strategically position some of this on the underside of the printer chassis, and then we can wind out the printer mounting post, which is what these things on the top of the calculator are. There's one at each side, and we can see if the calculator will properly mount. Unfortunately, you can't adjust this right hand one with the calculator assembled. You need to take the power supply out. So I'm hoping that this will be the right height once I've got the foam stuck onto the underside of the chassis. So I'll try that, we'll come back and see if it mounts properly. Okay, so I've got the foam stuck onto the underside of the chassis. I've got the mounting bolts screwed all the way out, so hopefully this will now fit onto the calculator. So we turn these two tabs all the way out, flip this upside down, or rather the right way up, and then these should fit over the two posts. These should swing in, and as you can see, there is no clearance or play between the chassis and the calculator. it's sitting down, it's not touching in the middle, so it's not going to scratch the case, and we've got a nice even pressure all the way along and a seal right to the front, so it actually looks quite nice. It's sitting on there nice and square and firmly, doesn't take too much pressure, but you can see that when I release this it does pop up very slightly, which is what we want. So you can see it's coming up a little bit, which is exactly how it's supposed to be, and when we push these in it's nicely secured and isn't going to move around. So that's come out extremely well. As I said, I'm just using here some fairly cheap dual rubber strip, self-adhesive, and very good adhesive on this. Once it's stuck on, it's not going to come off. Okay, so in the next video we can start reassembling the main printer body, start refitting the parts, and at some point we can get the print head hopefully repaired and start trying to get this thing to come back to life.